All right, welcome back. We are going to talk about example 3, but first, we have to talk about the segment addition postulate. Now, this is a really super important postulate. You're going to use it the entire year, and this needs to go on a note card or a flashcard immediately, and you need to memorize this. You need to know this one by the back of the hand. It's not going anywhere. It's not going away. You're going to see in chapter 1. You're going to see in chapter 2. You're going to see in chapter 3 and 4 and so on. Okay, it's all over the place. So, what this says is if B is between, so I'm just going to put this on here. So you need to be making flashcards, right? So this one needs to be a flashcard. Flashcard. It's a flashcard alert. Flashcard alert. Put this on a flashcard. Put it on a flashcard. That's what you need to do. Oh, thank you, Pause Dragon, but it's not your turn yet. Okay, so flashcard. Okay, what it says is that if B is between A and C, so here, B, oh man, that's a terrible looking line. I think it needs some help. Oh, yeah, I kind of see it. Okay, so right here, here's the line. Right here. Okay, this is the line. Okay, so if point B is between point A and point C, then what we know is that AB plus BC equals AC. All right, let's look at that. So this is saying that this segment, AB, plus this segment, BC, equals the whole entire thing. Sometimes I like to just put numbers on, and sometimes when I do numbers, then it just makes a little bit more sense. So let's say I have AB, and the distance between that is 3. And then the distance between B and C, let's call that 5. So what it's saying is that the distance between here is 3, the distance between here is 5, so what would be the whole distance from A to C? Well, all it's saying is you take 3 plus 5, and that will give you the whole thing, which would end up being 8. That makes sense, right? If you take this and you add it to that, then you'd have the distance of the whole thing. So that's the segment addition postulate, all right? And notice how it's written in symbols right there? And that's what we're going to be doing. We're going to be writing in symbols. So get used to that. Just let it soak in, accept it, because that's what we're going to be doing. So let's look at example 3A first. Example 3A says using the segment addition postulate. That's nice. Okay, so that's what this, we're going to be using this. It says G is between F and H. So what I like to do is I just like to draw a picture. It's just saying it in words, but I want to draw a picture because it just helps me visualize. So it says G is between F and H. So G is in the middle, right? And it's between F and H. Okay? Then it says FG is 6. So FG is 6. And then it says FH is 11. So that means this whole thing is, I don't even know how to write 11 up there, but that's itty bitty 11. Find GH. Okay, so this is the part over here that we don't know. All right, cool. So the first thing we're going to do is write this segment addition postulate with symbols. So I'm going to write this. FG okay, FG plus GH, so it's kind of the two parts, equals the whole thing, FH. And the reason why I can say this statement is because of the segment addition postulate, right? Then what I'm going to do is I'm going to input those values up here. So what did the problem give us? they gave us that FG is equal to 6, right? They gave us that, and then they also gave us this. FH is equal to 11, and that's actually called the given information. Whenever the problem gives you information, it's called the given, okay? So these are the two pieces of information that the problem gave us. So that is called the segment, that is called the given, okay? The problem gave us that information, that's called the given. We use this segment addition postulate because we just learned about it right up here, and we said, oh, hey, if I have this piece and this piece here, FG and GH, I can add those together and I get the whole, right? This part and this part makes up the whole thing, and which is called the segment addition postulate. Then what I'm going to do is I'm going to take these given values and I'm going to substitute them into our segment addition postulate. So FG, what's FG? Well, it's the same thing as 6, so I'm going to substitute 6 in for FG. I don't know GH, that's what we're trying to figure out. Plus GH equals, what is FH? Well, FH is the same thing as 11. So I'm going to substitute that in there. So what I just did, why I don't have this anymore, I have 6 and 11, is because I used substitution. That's what I did. All right, now I'm just trying to figure out what GH is. So I'm going to use, my algebra skills. Okay, I got to get rid of this 6. How do I get rid of the 6? Well, I subtract it to both sides, right? So now I have, and that, when you subtract to both sides, that's actually called the subtraction property of equality. Okay? And then I just, that cancels. And we have GH equals 11 minus 6, which is 5. And that's the answer. And whenever I do things like that, I take something that looks like this and I turn it into this. That's called simplifying. Simplify. Just simplify. Boom. And there we have the answer right there. GH equals 5. Now, for your problem, you have to do this right here. You have to do all this. Okay? That's what your work needs to look like. Now, if you want to write all those, you can. What we're going to be doing, everything that I just did right here, that is called a proof. And we're going to be doing a lot of proofs this year. And so I just like to start talking about proofs. So then when you actually start doing them, hopefully we've already had a lot of experience talking about them. But that's pretty much it. But for you right now, you just need to do that. If you want to go ahead and start doing that, you are more than welcome. But what you're going to find out in this geometry class is every time we write something, we have a reason why we write it. Why were we able to write FG equals 6? Why were we able to write FH equals 11? Because the problem gave us that information. It was given. That's the reason. Why were we able to write this? Well, we were able to write that because of the segment addition postulate, something we just talked about. And then why were we able to do that? Because of substitution. Why were we able to subtract from both sides? Subtraction property of equality. Why were we able to do this? Is because that's called simplifying. So in this class, there's never a, oh, you just do this, or yeah, that's just the way you do it. That's never good enough in this class. In this class, whenever you do something, you have to have a reason and you have to know the reason why you're doing this. Okay, and that's what makes this class like a high school level. It's an upper level math course, and that's really where we're going to go for the rest of the year. But for right now, this is all that's required. But notice this right here. I really, really want you to pay attention to this. Do you see this in symbols? You have to do that in all your quizzes and all your tests and all your homework. If you don't have that, if you just go straight to here, you will not get full points. You have to start writing in symbols, just like this. Okay, that's what you need to do. Okay, so just buy into it, get used to it, and the easier everything will be. Okay, let's go ahead and start talking about the next problem, example 3B. Okay, where is it at? Here it is. What does this say? Okay. This says that M is between N and O. We need to find NO. So it gives us this information. This is all of the given information right there. Okay? So it says M is between N and O. All right, find NO. We want to find the whole thing. So whenever you see this piece, this part here, and this part here, and you have the whole thing, right when you look at it, you should know that that's a segment addition postulate problem. So you can go NM plus MO equals NO. Boom. All right? You should be able to do that. So the first thing I like to do is always write down what the problem gives us. So what is the problem giving us right now? Well, the problem is giving us that MN is equal to 17. What else is the problem giving us? The problem is giving us that MO is equal to 3x minus 5. What else is the problem giving us? The problem is giving us that NO is equal to 5x plus 2. I need a plus there. And that is all given information. That is what the problem is giving us. Now, we see this part equaling the whole, so we automatically know this is a segment addition postulate. So I'm going to go ahead and write that. NM, and you have to write it using symbols. NM plus MO equals the whole thing, NO. And the reason why we can write that statement is because of the segment addition postulate. All right, now from here, we're just going to take these given values and substitute them into our equation. So NM is the same thing as 17, plus MO is the same thing as 3x minus 5, equals NO, which is the same thing as 5x plus 2. And the reason why we can do that is because of substitution. Now we're just going to, it becomes an algebra problem. From here, I think I'm going to simplify this side of the equation because I have a 17 and a negative 5. So 17 minus 5, that would be, what, 12? So 12 plus 3x equals 5x plus 2. So the reason why, when I combine them, that's called simplifying. Then I want to get the x's on the same side. I like to move the smaller one from 3x to 5x is 3x, so I'm going to subtract 3x to both sides. I end up with 12x equals, what, 2x plus 2. This was called the subtraction property of equality. Whenever you subtract to both sides, called the subtraction property of equality. Trying to get x by itself, so I got to get rid of this 2. I'm going to do the inverse operation, which would be subtraction again. So that again is going to be the subtraction property of equality. Subtraction property of equality. 12 take away 2 is 10 equals 2x. All right, then I'm going to get this x by itself, so it's multiplied by 2. So the inverse operation would be to divide both sides by 2, and guess what that's called? That is called the division property of equality, POE. And then 10 divided by 2 is 5 equals 2 divided by 2 is 1. 1 times x is just x, so x, right? So that's called simplifying. But whenever we're dealing with these problems, we always write x on this side, on the left side, and when we just flip it like that, that's called the symmetric property of equality. And you'll learn all about these properties in Chapter 2. I'm just kind of talking about them, giving you a preview. But for this problem, this is all the stuff that you're going to have to do right here. Write the given information. Do all the algebra. If you want an added challenge, go ahead and write the reasons down for it. But you are not going to be required to do this part until Chapter 2. Okay. So there you go. Oh, now it's your turn. Example 3A and example 3B. I want you to go ahead and try those on your own. So now is the time to pause. Make sure you do them in pencil because this is all going to be new. It's a lot of notation. I want you to think these problems through, try them on your own. However, there's a big chance that you're going to have to erase and write down exactly what I'm writing down. So for right now, go ahead and pause, try it. When you get done, press play and we will talk about it. All right, we are back. Let's go ahead and talk about example 3A. It states that y is between x and z. So I'm going to go ahead and just draw a little picture of that right over here. Seems like a good place. So y is between x and, why do I keep hitting this? Z. All right. It says xz is 3, so that's kind of the whole thing. I'm going to go like this. The whole thing is 3. Xz, oh, the whole thing is 3. Xy, is that 1 1/3? This is 1 1/3. Oh, we need to find is yz. We don't know this right here. So here we have it. We have another piece making up the whole. So a part and a part making up the whole. So that's obviously a segment addition postulate. So the first thing I'm going to write down is that given information. So what do we have? Xz equals 3 and xy equals 1 1/3. That is the given information. Then, just looking at this, it's a segment addition postulate. So commit that to memory. Whenever you got this part, and the whole, that is a segment addition postulate. So we're going to write it down. The segment addition postulate is this piece plus this piece equaling the whole. Xy plus, remember we're going to do it in symbols. You have to do it in symbols. So just buy in. Okay, that is our segment addition postulate. Then from here, we're going to substitute those given values in. So for xy, that is 1 1/3 plus yz. Oh, we don't know yz, so we just write yz. That's talking about the distance of that segment. Equals xz, which is 3. All right, perfect. And we just substituted, so that's substitution. Okay, and then we are going to isolate yz, so we have to subtract 1 1/3 to both sides. Does anybody know what that's called? Why we are able to do that? It is called the subtraction property of equality. If you got that right, great job. All right, those cancel. We're left with yz equals 3 minus 1 1/3. Okay, so I need to do this little fraction problem here. I need to make this this is 3 over 1, right? And I need a common denominator of 3, so I'm going to multiply both of these by 3. It's an itty-bitty 3. 3 times 3 is 9. I'm going to write that here. 1 times 3 is 3. And then this is a mixed number. I'm going to change it to an improper fraction. 3 times 1 is 3, plus 1 is 4 thirds, like that. Okay. And then we are just going to simplify this. And we end up with yz equaling 5 thirds. So that is simplifying. And yeah, that's our answer. Or we can change this into a mixed number where that would be 3 goes into 5 1 time. 1 times 3 is 3. There'd be 2 thirds left over. So there you have it. So if you got that, make sure you have the improper fraction and the mixed number. And make sure that you have all of this. If you have all of this, then you did a great job. Okay, if you don't, you need to change it and write down what I have. And really making sure that you have these symbols. Okay, don't start with the numbers. You have to start with just letters. Everything is in letters. All right, perfect. Let's see how you did on, check it out, example 3B. So that says E is between D and F. Find DF, which is the whole thing. So look at that. It gives us a whole bunch of given information. I'm going to go ahead and write down that given information first. So what is the given information? I have that DE is equal to 3x minus 1. And I have EF is equal to 13. And I also have the whole thing, DF equaling 6x. And that is the given information the problem's giving us. Okay, so what do I write next? Well, what is it giving us? This is a part, this is a part, this is a whole. Boom, it's a segment addition postulate. So I write the segment addition postulate. Just by looking at this picture, I know that it's a segment addition postulate. Piece, piece, whole, segment addition postulate. I'm going to write that down in symbols. So I'm going to write down, and I really want to magnify the fact that I'm writing in symbols. So DE plus EF, you have to write this down, equals the whole thing, DF. The reason why I can write that is because the wonderful, magnificent segment addition postulate, which now I'm like totally abbreviating. Perfect. From here, we are just going to go ahead and substitute. Substitute those given values in for the segment addition postulate. So instead of writing DE, I'm going to write 3x minus 1 plus EF, which is 13, equals DF, which is 6x. Okay, that's just substitution. And then we just, simplify. So right here I have numbers on the same side of the equation. So I'm going to simplify that. So I end up with 3x minus 1 plus 13. That would be a positive 12. Equals 6x. That's just simplifying when you do that. And then we want to get the x's on the same side. They're on two different sides of the equation. Since there's this one over here by itself, I'm just going to move the x over there. It just happens to be the smallest, which is like a win-win pretty much. So I do the inverse operation. This is positive, so I'm going to subtract 3x to both sides, which is called the subtraction property of equality. That cancels. I'm left with 12 equaling 6x minus 3x, which is 3x. That's called simplifying. And then I want to get x by itself, so I need to get rid of this 3. It's 3 times x, so the inverse operation would be dividing by 3 to both sides. So division property of equality. 12 divided by 3 is 4 equals x. 3 divided by 3 is 1. 1 times x is just x. So that's some more simplifying, but I always want to make sure that I write this x on the left side. So when I just flip-flop it like that, I can do that because the symmetric property of equality says I can. It just basically says that 4 equals x is the same thing as x equals 4. And so there you have it. You should have this right here, and it should look exactly like mine. If it doesn't, change it, erase it, make it look like mine. If you went ahead and you did all this too, awesome job. That is amazing. Okay, good work, good work, good work. All right. So that is it for example 3. We're going to talk about example 4 in a little bit. So I will see you in the next video. Bye-bye.